So, it's time for a new fart box. This time it's an idea that I wanted to implement for a while, and this is the rather messy prototype of that idea, and that is a fully portable, programmable drum machine. Now, I've been getting into 8-bit stuff lately, and I don't mean 8-bit guy, I mean the 8-bit synthesis. I already ordered a whole bunch of these, like I have 8 of these. These are the AY3 chips. These were used in, I think, the ZX Spectrum 128, the Vectrex, an Amstrad, I believe. All sorts of computers and also in arcade machines. Because I salvaged one of these. There you go, the AY3 8912A. This is a little sound synthesizer chip. Very 8-bit lo-fi glory, which I pulled out of the motherboard of a slot machine. So these things were pretty popular. I'd say almost, well, maybe not as wanted as the SID chip, but it's pretty much an equivalent, fully digital equivalent rather. So yeah, obviously I'm gonna build a polyphonic monster synth using all those chips. But I first wanted to get into the vibe of 8-bit and the gnarly lo-fi sounds that it offers. And yeah, I also wanted something portable because I do have to travel sometimes. That usually means I'm sitting in a train for 2 hours being bored out of my tits. So I really felt like I needed something that I could take on the road. This is the concept for that idea. It runs on an Arduino Uno that I had lying around. I'll probably end up using, well, obviously an Atmega chip, since I've already written the firmware for this now. But yeah, it has to be low power, and those Atmega chips, which are used in Arduinos, they are pretty low power. And well, obviously since this thing is going to be battery powered, there's going to be 2 9-volt batteries in here, in parallel, supplying 9 volts to the Arduino board. I do want something low power. That did mean, obviously, that I don't have many clock cycles to use. Don't have that much computational power. And this thing does not use samples. It's completely, well, synthesis based. It has a bunch of oscillators with various waveforms that you can choose. These go through a volume envelope and a pitch envelope. That's pretty much what generates all the sounds in this thing. That also means that the way this thing works and the way that you program it is not really like standard drum machines. Usually you have a predefined set of sounds, like a kick drum, snare drum, claps, hi-hats, maybe some cymbals or toms. I also started off like that with this thing, but I kind of ended up doing things differently. When I go to edit sounds here, you'll notice that it's sound 1, 2, 3, 4, 5, and 6. They're not called kick drum, hi-hat, snare, etc. And that's because every sound is the same oscillator, the same envelopes, with the same parameters. The way you set those parameters, that is what actually makes the kick drum, the snare drum, the hi-hat, etc. Now obviously that does mean the actual synthesis engine has to do a little bit more, ironically. But it also means that it's very flexible. Any sound can be anything. So a lot of ways you can shape the sound. You can also go crazy, as you obviously already heard in the intro. You can make them very non-standard, so to say. So yeah, just complete freedom, the way I like it. Just, you know, you can go mellow or you can go over the top, which is always fun to do. Now, the actual rhythms is also kind of different. This thing uses patterns. So if I go to edit patterns here, I'll just select pattern 1. So you can just program it, like, just like this. Patterns are not tied to any sound. There are 9 patterns in total, and those patterns can be assigned to any of the 6 sounds. And this means you can change patterns and the combinations of various patterns on the fly while the drum machine is playing. Again, this is to give more flexibility. Now, one thing I haven't added yet, but something that I really want to do, is odd time signatures. I'm a big fan of those. So every pattern is 16 steps, but I want to make it possible, probably with this knob here, to set the pattern to say 15 steps. Or if you want a 3/4 rhythm, you have 12 steps. So essentially you set how many 16th notes one measure has. And you can do that for each pattern. So you can have a 4/4 16-step pattern, like the one here, over a 9/8 or whatever you want. So you can make polyrhythms, which is yet another thing that adds flexibility and makes things a little bit more interesting and out there. Well, other than that, obviously there is a storage. You can load and save sounds and load and save patterns? Oh. Yeah, obviously that's still a work in progress. But yeah, load sounds, save sounds, load patterns, and then also save patterns. I'm not sure why that menu option isn't appearing, but oh well. That is all stored on the EEPROM on the Arduino. Well, let's go over the rest of the hardware actually. Obviously there's your volume button, which says the volume of the line out. There is also a volume button here for the headphones on the back here. So you can plug in some headphones. This is the line out. I want to add a little control voltage for the cutoff, which you can also set with a knob here. But you'll be able to manually set the cutoff frequency of the filter and also plug in something externally. So if you want to have like a rhythmic LFO effect on the filter, you can do that as well. Not sure what this is going to be, if this is going to be anything at all. Now this little output is a timing output. So this sends out 16th note pulses. So this thing can be synchronized to, another portable synth. I'm also planning to make a, maybe a wavetable synthesizer, or maybe a hybrid synthesizer, or maybe I'll make a little synthesizer, portable synthesizer with this chip, and be able to sync this drum machine to that synthesizer. This is really meant for jamming on the road, so yeah, obviously I needed something a bit more than just drums or rhythms. So that's what this little output or input is for. I'm kind of thinking of making this either or, so you can switch it in the main menu to output or input, so you can sync something with this thing or have this thing be synced to something else. I also want to implement this feature in all my other builds. The SQK synthesizer, the CB55 drum machine could easily be synced together using just this method. And any synthesizers that will have MIDI, such as the SQK, such as the CB55 drum machine, they can also act as a MIDI to sync interface. Well, and furthermore there is a USB to update the firmware, and there's also a 9-volt DC input. And finally there is a switch here which turns the battery power on and off. That's kind of it. You already seen these two knobs in action. They are for editing sounds. So you can essentially have 2 parameters per option. You can switch to the options with the keypad and just change values, whatever you like. And obviously, while the drum machine also is playing, I'll probably dig around with this prototype for quite a while still. So yeah. Anyways, see you guys later. Bye.